Okay, good morning, students. In this lecture, we will discuss a new topic, that is reprogrammable gate array. In previous lecture, we already discussed that. In previous lecture, we already discussed that the programmable gate array are of the two types. One is ad hoc and another one is structured array, and we discussed ad hoc array in that topic. Okay, so this one is the next topic of reprogrammable gate array. In this lecture we will discuss about structured array. That is the second part of reprogrammable gate array. This one is the programmable reprogrammable gate array, and we already discussed one of its part, that is ad hoc array, in our previous lecture. Now in this lecture we discussed about structured gate array. uh, the structured gate array pattern is generally used by a company, that is Algotronics, for making their programmable devices. Here I am taking one of its FPGA example, that is CAL1024. CAL1024 is implemented by this Algotronics company. This FPGA is one of the best example of structured array. Okay, so in this FPGA, or in this structured array, you can see there are the several logic blocks. These logic blocks are known as logic cells. Generally, FPGA uses logic blocks combination according to their requirement, but um, by default it consists 32 rows logic cell as well as 32 columns logic cell. That means it form a 32 cross 32 matrix. Okay, suppose here we can see there are the two rows and three columns, so we can say this one is the example of two cross 3 matrix. But in FPGA CAL1024 FPGA, 32 rows are there as well as 32 columns are there, and in each intersection of rows and column, each intersection in rows and column, one logic cell is present. This logic cell is nothing but a memory element. Okay, this logic cell is nothing but a memory element. You can see each logic cell consists interconnection with their neighbor logic cells. Here you can see each logic cell, these are the logic cell, these are connected with their neighbor logic cells. So accordingly, it form to east input, to west input, to north input, to south inputs. Okay, one is input, one is the output, one is the input, one is the output. So we can say one east input, one east output, one north input, one north output, one east input, one east output, one west input, one west output. That means I want to say that each logic cell consist connection with their neighbors, and accordingly it provide one output and one input. You can see two horizontal lines are there. These are connected with logic cell. These horizontal lines are known as global signals. These horizontal lines are known as global signal. Now what is the mean of this global signal? These global signal is used to provide the globally circulated signals to all logic cells. That means it can use to provide supply, it can use to provide any clock signals. When we are dealing with the when we are studying about the clock signal, then there are the two types of clock signal. One is synchronous and another one is asynchronous. When all logic cells find the clock signal simultaneously, then this type of clock is known as synchronous clock. Okay, so when we provide synchronous clock to all logic cells, that at that time some delays are there. These delay are known as low skew. You can find it in your theory portion also. Low skew signals, this signal is also known as low skew signals. The delay in clock of one logic cell and another logic cell is known as low skew rate or low skew signal. It is generally a clock signal. So by using these global signals, you can provide the clock signal, you can also provide the supply to these logic blocks. um, each logic cell consists a RAM. Each logic cell consists a RAM element for the storing purpose. We know that how can we implement RAM. For implementation of RAM, there is some word line, there is some bit line, and when when there is some interconnection between bit line and word line, then memory cell is formed. So for making a RAM, there are various there are various rows line as well as bit line passes through each logic cell. Okay, so each logic cell is connected with RAM cell also. So this is all about, so this one is all about the theory portion for these generalized logic cell and its interconnection. Okay, one more thing is there. You know that we know that here 32 logic cells connected into rows side, and 32 logic cells are connected into column side. So when we need to provide when we need to provide some input to this FPGA, or when we want to extract some output from this logic cell, then at that time we can take this input, or we can provide this input or take the output from the four sides of this FPGA. So each side there are the 42 input output pads each side. When we are dealing with this side, when we are dealing with this side, or when we are dealing with bottom side, or when we are dealing with our outer upper side, each side consists of 32 input output ports through which we can provide the input to this logic cell. We can also say the input output cells, the input output terminals are present in the boundaries of these logic structure. Okay, the theory portion is mentioned here. You can study this theory portion. Okay, now uh, I have made a internal structure of these logic cell. This one is the internal structure of logic cell. Here you can see that there are the four multiplexers are present. One provide the north output, one provide the east output, one provide the south output, one provide the west output. Also the each multiplexer consists of four inputs. The connection of these overall connection is present inside each logic cells. So this one is the internal connection of this rectangular block, or we can say the logic cell. Okay, so you can see there are various multiplexers are connected. So by using this pattern, we can when we want when we provide a north when we provide a north input when we provide a north input to to this multiplexer. So by proper selectioning of this selection line, we can find the output from this east output also. When we provide north input and want the output from east side, then by using a proper selection we can find out these all type of functions according to our requirements. These all are the inputs and global selection lines. We already stated that in logic cells there are the north input, north output, east input, east output, also with their some global lines are present there. So all these are mentioned here. You can also you can you can see the this internal structure. By using this internal structure, various type we can find out various types of function. The logic functions is mentioned here. There are the 20 logic functions. There are the 20 different logic functions. That means we can multiply, or we can ended operation with a negative x1 x2. We can use it by we can use it as a or gate. We can use it as a nor gate, or x nor gate can use it as a d flip flop. These all logic functions is possible by providing, or by using a proper selection line in this multiplexer circuit. Okay, now these all these are the theory portion that is related with these are the theory portion that is related with the internal structure of this logic cell. Now there is one more structure of algotronics companies is there, that is known as input output pad structure, that is known as input output pad structure. Now this one is the input output pad structure. In input output pad structure, we can see that here there is one input output port. This one is the outer side, this one is the output side to the chip, this one is the input side of the chip. That means we can provide input from this side, we can take output from this side. But this one is the bidirectional input, this one is the bidirectional port. That means we can provide the input, we can provide input from this side also, we can take output from this side. Okay, so at that time we know here the we know here there are two output sides. One is the output of NOR gate, another one is the this input output. But when we use this port as an input, at that time this input is provided to the NOR gate, and the second input is provided from the chip, and accordingly we can find out the output from this side. But what happened when we use it as output port, when we use it as output port also, we use this port as output also. At that time this condenser detection circuit plays a role. At that time this circuit drives the both output, this output of NOR gate as well as these output of input output pad. Okay, so this one is the circuit, it is attached with algotronics. When we need more than one output from the from the kit or from the chip, at that time we can use this circuit. Okay, so this one is some theoretical portions, theoretical portion. You can you can you can go through it, such as the design is similar to Xilinx and Actel approach. All these are the theoretical approach. Now at last, we can already see in a structure that there are the 32 rows as well as there are the 32 columns. Accordingly, 1024 cell logic 1024 cell logic chip is present there. But according to the requirement, we can change it. That means that if I want to use this FPG as a single bit adder, that at the time only four logic cells are required. But at the time when we use this for a 32-bit ripple carry adder, then at the time 122 cells are required. When we use it as a 8-bit adder, and at that time fully the 1024 cell logic cells present in the FPGA is used at that time. The speed of this operations is approximately in the range of 500 nanosecond. This one is the approximated range. So this one is the completion of our reprogrammable gate array approach. So in next class we will see the next topic, that means C of gate array. Okay, thank you so much.